Simufact forming is a user-friendly environment for the analysis of many different metal forming processes. Its functionality has been further extended to capture mechanical joining and pressure welding applications also. This workshop gives a first impression how to work with this tool. Each section contains a commented video tutorial and provides the opportunity to reproduce its content on your own. Okay, this is a brief introduction to the Simufact forming user interface. First of all, I would like to open a previously defined project. So I just hit the Open Project icon, select a project file, and now I see it's being opened. So the basic window layout of the user interface is as follows. On the left hand side here we have our Explorer window. In this Explorer we see some kind of tree structure, and this tree structure represents the whole analysis model. Here in the middle is the so-called object list or object window. In this list we have different kind of objects which are being used in a particular manner in the analysis process. And the main part, of course, is the model view window. In this model view we have parts or the whole model being displayed. Okay, if the mouse is within the model view, you can see how the pointer changes its shape, and the default setting is that we are in model rotate view, which means just left clicking and dragging enable us to rotate the view on the model. So the model itself is of course not changed in its spatial position, but only the view is adapted. So in the lower left we see there are icons where we can control the behavior of the mouse. So if I switch here, I can switch over to the pan mode, which means in this mode I can translate the view to the model in space. And you see also the mouse pointer has changed its shape. Of course, camera zoom is also available. So if I just use this button, then I'm in zoom mode. Okay, so the default setting is the camera rotate, and I'm switching back to this mode again. There's an option to temporarily switch over to the translate mode. So if you press down the shift key on your keyboard, then you can temporarily switch over to translate mode, which makes navigation through the model view pretty simple. To reset the view back to its standard position, we have the small home button here, which always brings you back to a view to the ZX plane and fitting the whole model. There are some other predefined view settings indicated by the coordinate frames here, so we can switch over also to the XY view, to an isometric view, and different other options. There's also a rubber band zoom feature. This is located here, so clicking it, open a rubber band box will zoom in the particular region, and again clicking on the home button brings us back to the standard view. Okay, in the model tree we see there are certain objects, and it is possible to select objects. So simply by clicking on an object, we see there's a small exclamation mark on the object, which indicates that this object is being selected. On a selected object, we can do certain manipulations. What I'm going to show you now is simply to change the visibility of this object. Here in this icon list, we can change the way how the object is being displayed. So here we see the shaded view with grid lines. Here we see only grid lines. In this view we have the shaded view with the edges being displayed. Here we have a certain kind of transparent view, and finally we can hide the object also by making it invisible. Okay, so using the selection and changing the view of the selection enable us to display each object in a different way. Okay, that's all for this tutorial. Okay, in this video I'd like to show you how to create an analysis model for a simple cold forming operation using Simufact forming. So as we can see here, we have already a process tree with a couple of objects defined here, and all the necessary objects to create the model are already imported to our object window. So to model or to create the model, I just drag the objects on a right position in the process tree. So the billet object should be assigned to the workpiece, of course. This is being done, and the tool components are dragged over to the objects on the process tree also. So ejector is assigned, the lower die is assigned, lower die 2 is assigned, and the upper die is also assigned. I can see that my model view is now filled with all the geometrical objects here. And just to make it better visible, I switch over to transparent view, and now I can see the different components. We can also see, if I just hide the billet object and make the upper die object solid, now we see that the geometry already is in the end position, so in the position which is reached at the end of the forming process. This is the favorite way to create the CAD data, because in this case it is not necessary to specify any strokes. Okay, so the geometry is now completely assigned to the process tree. Then I have also to assign the material record to the billet, which is the only deformable part in my models. All the other components are assumed to be a rigid material, so they can't deform, they're just defined by their geometry. The upper tool, the upper die, is moving with a certain characteristic, with a certain speed, and this is being defined in the press object. So I have also to drag the press object on my process tree and have to assign the upper die object on this press object. So now the program knows the upper die is being moved by the press, and all the other tool components are well, fixed in space. Of course, there's friction in the contact between the dies and the workpiece. These frictional characteristics are stored in the friction object, and I can assign it directly to the process name. In this case, it is automatically dropped to all the objects which are used in this process. The same is necessary for the initial temperatures, the initial temperature objects here. So again, I can drag them over to the process name, release the mouse button, and they are assigned to all the tool components, and the billet temperature, the initial billet temperature, need also to be assigned here. The last thing which is necessary when modeling is creating a mesh on the billet. So we see here we have a mesh object below the billet object. Just double clicking on it opens up the mesh dialog, and in this case the program suggests certain element size, and hitting the create initial mesh button will use this default element size on my model. Just click OK to use this mesh both as initial mesh and also for remeshing. Hitting the yes button creates the remesh object automatically here on the billet. So that's all. I can save my model and hit the start analysis button to submit this model to analysis. Thank you for watching. Okay, in this tutorial I'd like to show you how to import CAD data to Simufact Forming. So the most convenient way to import objects to the object window is just to right click in this window and choose items from the context menu. In this case, when importing geometry, I just open the geometry CAD preview dialog. This dialog enables us to well, select the import options which are being employed. As you see in this dialog, there are a couple of different geometry types which are being supported by Simufact Forming. So we have standard CAD interfaces like IGES or STEP, and we have also direct interfaces to ProEngineer, CATIA, and so on. So for this example, I choose the STEP format, and now I see all the step files being listed in the dialog. I'm just selecting the first one, and to ensure that the unit system which is being used for import is set to millimeters, I just specify it here in the dialog and hit the open button. And now I'm in the CAD preview mode. So the preview mode allows us to well, select certain options, how this CAD data is being translated for Simufact Forming. It is important to know that all CAD geometry has to be converted to triangular faceted geometry, and this is being performed by the CAD preview dialog. So just using the default options and hitting on the preview button imports the model or meshes the model with those triangular facets. And so now we can have a look to this model. You see in the CAD file are different objects which are automatically being separated, and now I can see the facetting using the automatic estimation of facet size. So if I would like to change the facet size, I just switch off the little checkbox here, and well, maybe I'm going to increase the facet sag from 0.0875 to 0.2. Again, clicking on the preview button. So now the model is being internally deleted and again imported with the new settings, and we clearly see now the facets are a bit coarser. On the other hand, of course, I can reduce the facet sag to, for instance, 0.05. Again, hitting the preview button re-imports the model with the new option. So now we see the facets are a bit smaller and they are able to represent the analytical CAD surfaces with higher accuracy. Another option which might be interesting is to switch off the quality facet mode. So the quality facets always try to create triangles with even edge length. On the other hand, the standard mode creates the typical STL-like representation, where we just make sure that the geometry is being represented by the facets pretty well, but in this case we create facets which might have very long edges in one direction and very short ones in the other direction. So this option, of course, reduces the number of facets which are being created, which reduce the global model size and reduce the computational efforts. But in general, this approach is not recommended, so the default setting always use the quality facet checked. Okay, finally, we are going to use these settings, re-importing the geometry and finally hit the import button to create objects from the geometry. So again, I have to specify a name for the project, and now I see the CAD geometry is being listed in my object box. So just double clicking on these objects brings up their property window, and I see that the geometry is being properly converted to STL data. Of course, I can rename those objects here in the list, so to make their object name a bit shorter, can just click on this object, enter the edit mode and modify their name. Okay, that's all for this video. Thank you for watching. Okay, in this video I'd like to show you how to use the auto shape option to create simple geometry. So the default way or the preferred way to use geometry inside Simufact forming, of course, is to import this geometry from CAD files, but sometimes it is necessary to create some auxiliary geometry, or also to create the billet geometry, which is normally a certain simple shaped geometry. So creating geometry using the auto shape can be accessed in the context menu of the object box by selecting geometry auto shape, and then the dialog comes up and it has certain options as seen here. So we can cube-shaped object, or cylindrical, hollow cylinder-shaped, or finally rounded cubes can be created. So just using the cube option, I can specify the dimension of the cube. So for instance, if I would like to create a plate with a height of 1 millimeter thickness and width of 100 by 100 millimeters, I just fill in the numbers and hit the OK button, and it creates the object here. Again, I'm just in the name edit mode and may rename it by plate 1 by 100 by 100. Okay, so double clicking on this object brings up again the property dialog of this object, and here again I see that the auto shape has created this plate for subsequent use in the analysis model. So of course there are other options. You may play around a bit. Another one I would like to demonstrate is the rounded cube. So if you think about billets or preform for hot forging operation, in this case we have normally cube-shaped geometry, which is being rounded on one direction. So if I have just a brick with a width and depth of 100 millimeter and maybe a height of 300 millimeters, and I would like to create rounded edges in the height direction, I just select the radio button on round height and specify a fillet radius, for instance 2 millimeters, and again hitting OK creates this rounded cube object. So I rename it to brick 100 by 100 by 300. OK, and again double clicking on this object. Let me show the shape of the object. Okay, that's the way how to create simple geometry in Simufact forming. Thank you for watching. Okay, in this video I'm going to show you the usage of the align bounding box feature. So in general, if we have objects in our model which are not correctly positioned in space, I need some functionality to do the positioning, and a very effective tool is using the align bounding box feature. A bounding box is a virtual cube which is aligned along the global coordinate frames, and this box has 6 faces for each coordinate direction, the minimum and the maximum, and of course there's also a center face. And we use these bounding box to position objects against each other. So if we would like to position the billet directly on the top surface of the plate, I right click on the billet object and select the align bounding box option from the menu. Dialog comes up, and now I would like to align the Z minimum face of this bounding box and would like to align it with the Z maximum face of the bounding box of the plate. So I select Z max, hit the OK button, and now we can see the object is directly on the surface. Of course, we can use this feature also the other way around. So I can right click on the plate and invoke the dialog. And now I'm going to center this plate on the middle axis of the billet. So I select for X and Y the center option, and for the billet I choose also in X and Y the center option, hit OK, and now I see the plate is moved to be in the center position of the billet. That's all. Thank you for watching. So in this video I'm going to show you how to select material data from Simufact's material library. Again, we are using the context menu of the object window and hit the material library button. This opens up the Simufact material library. As you see here, we have more than 600 different records in our library, and the easiest way to select the material out of those records is of course to search for a particular name. So if I'm looking for an AISI 6150 steel, I may simply enter the number 6150 and automatically all the records in the library which have this AISI codes are listed now. So this is one option. Maybe of course I can also search for the German name, so inserting the 50CR V4 brings up a particular name, a particular record for this name. Sometimes you might also want to filter the material records which are available in the database. For this purpose we do have the filtering option. So if we just remain on this AISI 6150 material, maybe we need some microstructural analysis of this material, so we might choose the microstructure material properties. This is a filter which just reduces dramatically the number of material records. So we have just 25 material records with microstructural data. And again, if I just go in the search dialog, enter the 6150, I can directly select a material record of my material, including the microstructural data. So hitting the OK button imports this material from the Simufact material library, which is a read-only library, and this material record is now copied into my project, and internally in my project, of course, I may also change entries. So if you just look in the header of the dialog, the read-only information is vanished. So now I'm allowed to change the entries in this dialog. So maybe we just have a look in to the data which is being stored in this record. So we see, of course, some general properties. The most interesting thing is if we just enter the datasheet tab here because in this data sheet we have a very nice summary of all the material data which is being provided in this record. So we see the general properties, chemical composition, and we see the mechanical properties, so Young's modulus being supplied dependent on temperature. We see constant Poisson ratio, constant density, and so on. We see the thermal properties which are being provided, and a lot more. The most interesting thing, of course, are the flow curves which are being used in this record. And so again, we see here in the entry list for microstructure that the Matilda microstructure model is available in this record. Okay, so to use this material record in your analysis model, simply drag it on your workpiece object, and now this material record is assigned to the analysis. Thank you for watching. Okay, in this video I'm going to show you how to use the advancing front 2D quad measure to create meshes on the sheets for this clinching analysis model. So as you see in the graphical window, the model is created in CAD using a 3D model. We see different components like the punch, the blank holder, top and bottom sheet, and the die. Okay, by double clicking on a mesh object for the top sheet, I enter the meshing dialog, and in this dialog we have already chosen the advancing front quad meshing algorithm, because this is the default algorithm for 2D models. You also see that the program has created a cross section, so it knows from your previous settings that we would like to run a 2D analysis. So it created already a cut through the model. In this cut, the local X direction refers to the radial direction, and the local Z direction refers to the actual direction of the model. So as always, the program automatically suggests an element size which seems to be appropriate for this model. I just modify this element size a bit to 0.2 millimeters, and now I can create an initial mesh on the model. So this initial mesh is not too bad, but we would like to employ certain refinement, and Simufact offers with refinement boxes a very nice way to define certain regions of the model, certain parts of the model which should be meshed finer, and this information is also kept for the remeshing which is taken place during the analysis if the remesh criteria are fulfilled. Okay, to get a better impression of the model, I'm just switching on the complete model view inside this remeshing dialog, and now we see not only the actual mesh on the component but also the surrounding tools. And with this view I can bring the refinement boxes dialog into front and add a new refinement box to my model. Okay, this box is now displayed here, and a nice feature is that I can simply hover the mouse over one edge of this box, click and drag it to increase the size of the box. Okay, and using this feature, I'm just creating or adapting the box that it fits more or less the region of interest in my model. So in this way I've made sure that the region inside this box is being meshed finer than the outer region. So if I now create the inertial mesh again and zoom inside, you can see how the mesh size decreases when I'm outside the box. Okay, by hitting OK, I can leave the meshing dialog, and I'm going to be asked if I would like to use this definition for the refinement box also for the remeshing during the analysis. So normally you hit yes in this dialog. Now I see it takes the refinement box in the global model and it has created automatically a remesh object in the process tree. Okay, thank you for watching. Okay, if you have set up the analysis and submitted the job, you might notice that after some time you get an additional result object on your process tree. This indicates that results are available for post-processing. So you can do post-processing even if the analysis is still running, at least up to the point where the computation actually is. So the easiest way to do the post-processing is to open the list of available result variables, and for convenience I close the object window to get more free space in the viewport area, and then I can simply select all components, because only the components which are selected are being used in the post-processing, and then I can double click on a result variable and it creates an animation window. In this animation window I can push the play button, and now I can see how the model deforms and how the state variables evolve in the deformed structure. Of course, you can do all the model manipulation you know already from the pre-processing window. All these manipulations can also be applied to the post-processing window. So we can of course rotate the view of the model, we can zoom its size, and we can translate it. Of course, it can be also reset to the default position, and we can also change the display behavior of the different objects. So I just selected the top sheet, and now I can switch to the meshed view, or I can switch to transparent view, or even to invisible view. So everything the same as we know already from the pre-processing. Okay, sometimes it is more convenient to have a three-dimensional view on two-dimensional results. This can be done also in Simufact forming. In this case, you just switch the expand 2D result button, and again we have to select all the components to create a result animation. And now I recreate the plot by double clicking on the desired result variable. So I did this, and now I see I have the view to a three-dimensional model, and this is just accessing the 2D result and has expanded these 2D results in a three-dimensional model. Of course, it is also possible to save these animation to AV files to use them for your final report, for instance. So this can be easily done by hitting the file button, and then I can create a file name. So for instance, equivalent plastic strain, and then from the current view AV file is created for subsequent usage. Okay, that's all. Thank you for watching.